Okay, so I bet you're kind of curious about those large language models, LLMs, and like how smart are they really?
Well, we're diving deep into this technical report. It's called Are Your LLMs Capable of Stable Reasoning?
Ooh, sounds intense.
It is, and it might just change how you think about AI, like those systems that write and code and can answer like anything.
Right. Like, are they truly intelligent or is there something else going on?
Yeah, in this report, it suggests that even the most advanced LLMs, they might not be as reliable as we think.
Really?
Yeah, especially when it comes to complex reasoning.
So, like, they can write a poem, but maybe not solve a tricky logic puzzle.
Kind of, yeah.
Yeah.
The researchers are proposing a whole new way to evaluate how LLMs perform, and it goes beyond just getting the right answer.
Okay, so it's not just about being right or wrong.
Right, it's about consistency.
Ah, so being right consistently. Gotcha.
Exactly. See, traditionally we've used these metrics like pass at K.
Pass that K.
Yeah, it basically tells you how likely an LLM is to, hit the right answer within a certain number of tries.
Okay, so like, if it gets a few chances, can it eventually figure it out?
Yeah, but that doesn't really tell us if it understands the problem, right?
Good point. It could just be lucky.
Exactly. Like, imagine a basketball player who, hits a three-pointer once. Does that make them a sharpshooter?
True. One good shot doesn't make you Steph Curry.
Haha, exactly. So, Pasek shows us the potential, but doesn't really tell the whole story.
Right. We need to know if they can consistently hit those three-pointers when it really counts.
Precisely. And that's super important when you think about LLMs being used for critical tasks, right? Like medical diagnoses or legal stuff.
Yeah, in those situations, you can't just rely on a lucky guess.
Yeah.
You need to know the AI is going to get it right pretty much every time.
Absolutely. And that's where this new metric comes in. It's called GPass at K.
GPass at K. What's that all about?
Well, it measures how often the LLM gets the right answer across all of its attempts. So it shows how stable its reasoning is, under pressure.
Ah, so it's like seeing how that basketball player performs in a real game, not just practice.
Exactly. And to really put these LLMs to the test, the researchers created this thing called Live Math Bench.
Live Math Bench. Sounds like some kind of intense training ground for AI.
It kind of is. It's a collection of seriously challenging math problems taken from all sorts of competitions, like, CNMO, CCEE.
Oh, wow, those are tough.
Yeah, and even, the AMC.
Oh, okay, I've heard of that one. It's for high school students, right?
Yep. And they even threw in problems from the Putnam exam.
Whoa, hold on. The Putnam exam. That's like notorious for being super difficult.
Right. It's not just about knowing formulas. It's about, like, really understanding how to solve problems.
So they're really pushing these LLMs to their limits with this live math bench thing.
Oh, yeah. And here's where it gets interesting. They tested all sorts of LLMs, even those enhanced with chain of thought.
Wait, chain of thought. What's that? Sorry, you kind of lost me there.
Oh, no worries. It's basically a technique where the LLM, you prompt it to like explain its reasoning step by step instead of just giving an answer.
So instead of just saying the answer is 42, it has to show its work.
Yeah, exactly. Like, here's how I arrived at 42.
Gotcha. Makes sense. So were these chain of thought LLMs able to, you know, crack the live math bench code?
Well, here's the thing. Even the top performing LLMs showed a big drop in accuracy when they were measured with that GPass at K.
Oh, really? So even when they had to explain their reasoning, they weren't as consistent.
Yeah, and we're talking about a significant drop. For the Llama 3.18b Instruct model, it was a 95.7% drop.
Wow, that's huge. So just because an LLM can sometimes get the right answer doesn't mean it really understands what it's doing.
Right, and this was across different types of LLMs, including ones specifically designed for math.
So even the math whizzes weren't immune to this.
Nope. It seems like scaling up the model size, making it bigger, doesn't necessarily lead to better reasoning.
So bigger isn't always better in the world of LLMs. That's interesting.
Yeah, and that means there's a gap between what LLMs can do and how consistently they actually do it.
So it's like they have the potential to be brilliant, but they're not always reliable.
Right. And that has big implications for how we think about using them in the real world, right?
Absolutely. We can't just assume an LLM is going to get it right every time, especially with complex tasks.
Exactly. And the report, it digs even deeper into this. They actually experimented with what they called contaminating the training data for LLMs.
Contaminating the data. Okay, hold on. Before we get into that, can you explain what that means?
Sure. Imagine you're giving students a test but you accidentally give them some of the answers beforehand.
Ah, so it's like cheating.
Yeah, kind of. In this case, data contamination means that the data used to test the LLM overlaps with the data it was trained on.
So it's not really solving the problem, it's just regurgitating information it's already seen.
Exactly. So the researchers intentionally contaminated the training data, and guess what happened?
I'm guessing the LLM's accuracy went up on the contaminated data.
You got it. But here's the crazy part. It actually became less stable overall.
Wait, what? That doesn't make sense. You'd think more correct answers would make it more reliable?
Right. But it seems like LLMs are really good at recognizing patterns, and mimicking correct answers.
So they're not really understanding the concepts, they're just parroting back what they've seen before.
Exactly. And that's a little bit concerning.
Yeah, because it means we can't just assume an LLM is reliable because it does well on a certain data set.
Right. We have to consider how it was trained and if it can apply its knowledge to new situations.
It's like they can ace a test if they've seen the answers before, but they struggle when faced with something truly new.
Right. And that raises a lot of questions about how we should be using these LLMs in the real world.
Definitely. So where do we go from here? What does all of this mean for the future of LLMs?
That's what we'll delve into as we continue our deep dive.
Sounds like we got a lot more to unpack.
It's like they can solve those textbook problems, But when it gets to the real world, it's not so clear.
Yeah, it's a bit like they can follow the recipe, but they can't really improvise in the kitchen.
Exactly. So, this research, it kind of makes us think twice, about relying on LLMs for everything.
Especially for those really important things like you said, healthcare,
Right.
finance.
Like, imagine an LLM is analyzing the stock market.
Ooh, yeah. Trying to predict what's going to be the next big thing.
Right. And it's not consistent. That could lead to some pretty big mistakes.
Yeah, people could lose a lot of money.
Exactly. Or, think about self-driving cars.
Oh, yeah, that's a big one.
If the LLM that's, controlling the car isn't consistent in its reasoning.
That could be really dangerous.
Yeah, disastrous even. So this research, it's really showing us that we need to shift our focus.
From just making LLMs bigger and more powerful.
Yeah, to making them more reliable, trustworthy,
Right. But if scaling up isn't the answer, then, well, how do we improve their stability?
That's the million-dollar question. And the report, it doesn't really give us all the answers.
So it's more like they're pointing out the problem and saying, hey, this is something we need to figure out.
Yeah, exactly. It's like a call to action for the whole AI community.
So instead of just looking for a quick fix, we need to rethink how we approach LLM development.
Absolutely. We got to go beyond just measuring how accurate they can be. We got to focus on making them consistently accurate.
So it's not just about having a student who can sometimes get the right answer, but a student who really understands the material.
Perfect analogy. And maybe that means we need to change how we train these LLMs.
So less about just feeding them tons of data.
Right. Maybe we need to teach them to think more logically, to understand cause and effect.
Like teach them how to think, not just how to memorize.
Exactly. And there's some exciting research happening in those areas, like using ideas from cognitive science to train LLMs.
That's really interesting. So taking what we know about how humans learn and applying it to AI.
Yeah. And maybe we'll even need to come up with new ways to evaluate LLMs.
Something that goes beyond just GPAS-AK.
Right. Maybe metrics that can assess how well an LLM can explain its reasoning or how well it can identify its own limitations.
Oh, wow. Like the AI is saying, hey, I'm not sure about this part.
Exactly. That would be huge.
Yeah, it would change everything about how we interact with LLMs.
Absolutely. Instead of just taking their word for it, we could have a real conversation with them, understand their process.
It's like they become more like partners in problem solving rather than just tools.
I like that. Partners. And that means we need people from all sorts of fields to work together.
Not just computer scientists.
Right. We need linguists, cognitive scientists, even ethicists.
It's a big team effort.
It is. Because this isn't just about building cool technology. It's about shaping the future of AI.
Making sure it's something that benefits everyone.
Exactly. This deep dive, it's really showing us how big this conversation is, right? It's not just about math problems.
No, it's about how we use these incredibly powerful systems in a responsible way.
Right. So for all those people out there who might be using LLMs in their daily life,
Which is probably a lot of people these
it
days.
means we got to be careful, right? We can't just blindly trust everything an LLM tells us.
Always a good idea to be a little bit skeptical.
Exactly. And for businesses, who are using LLMs, they got to be extra cautious. Think about the risks.
So maybe we'll start seeing more of these hybrid
Oh,
systems.
yeah. Combining LLMs with other types of AI or even human oversight.
Right, so there's always a human in the loop just to make sure things are running smoothly.
Exactly. It's all about finding that balance,
Yeah.
harnessing the power of LLMs, but being aware of their limitations.
And speaking of limitations, the report talks about how an LLM's stability changes depending on how difficult the task is.
Oh, right. They use those different math competitions to explore this, right?
The CCEE, which is for high school students, and then what was it called?
The WLPMC, that's a super challenging one for college students.
Right, right.
Yeah.
So were LLMs able to handle the tougher problems as well as the easier ones?
Well, not really. They did pretty well on those CCE questions. But when it came to the WLPMC problems,
Their performance dropped.
yeah, it seems like their reasoning, it's a little more fragile than we thought.
So it's not just about how stable the LLM is in general, but how it performs under pressure.
Exactly. And that means we need to be realistic about what we're asking them to do.
Right. We can't expect them to be perfect in every situation.
And it also means we need better ways to test these LLMs, right?
Like Live Math Bench, but even tougher.
Right. Data sets that can really push them to their limits and show us how their reasoning works in different situations.
It feels like we're just starting to understand these LLMs. Each new study reveals something new.
It's like we're piecing together a puzzle.
Exactly. And every new piece gives us a clearer picture of how they work, their strengths, their weaknesses.
In every new insight, it leads to more questions.
Like, how do we make LLMs more stable? How do we use them ethically?
It's exciting, but it's also a little daunting. We're dealing with something really powerful here.
We need to be careful, but we also need to be open to the possibilities.
Absolutely. We're at the beginning of a technological revolution, and it's up to us to shape it.
This deep dive has been really eye-opening.
It has. We've covered a lot of ground, but there's still so much more to explore.
This is just the beginning of the conversation. It really makes you think, you know? Like, we're trying to create artificial intelligence, but it's making us question what intelligence even is.
It's true, we're realizing that intelligence, it's not just about processing power, or memorizing facts. It's got to be more than that.
It's got to be about being able to adapt, right? Like, think on your feet.
Exactly. And you know what? That's what makes this whole field so exciting. We're not just building tools, we're pushing the boundaries of what we thought was possible.
It's kind of like we're learning about ourselves by trying to create something that's, well, not human.
It is a paradox, yeah. We're trying to build something we don't fully understand.
And that's what keeps things interesting, right? There's always something new to discover.
Absolutely. And this research on stable reasoning, it's just one piece of the puzzle.
Right. There's so much more to explore.
Like, how do we train these LLMs differently? How do we create better benchmarks?
And how do we make sure they're used ethically? That's a big one.
Huge. I think in the coming years, we're going to see a lot of focus on making LLMs more transparent.
Transparent, what do you mean by that?
Well, right now, they're kind of like black boxes, We put in data, they give us answers, but we don't really know what's going on inside.
It's like they're doing their calculations on a hidden chalkboard, and we only see the final result.
Exactly. And that can be a little, well, unnerving, right?
Yeah, especially when you're dealing with important stuff.
So I think we'll see more research into creating LLMs that can actually explain their reasoning.
So it's not just, here's the answer, but here's how I got to the answer.
Right. And maybe even, point out where they might be uncertain.
Oh, wow. So the LLM could actually say, hey, I'm not totally sure about this part.
Exactly. That would change how we use them,
We'd be able to have more of a conversation with them rather than just blindly trusting their output.
Right. They'd become more like partners, collaborators.
I like that. Partners in problem solving.
And that means we need to bring in expertise from all sorts of fields.
Not just the computer science folks.
No. We need linguists, philosophers, people who can help us understand the human side of intelligence.
It's a big challenge, but it's also incredibly exciting.
It is. We're really pushing the boundaries of what's possible.
This whole deep dive has really made me think differently about LLMs.
Me too. It's shown us that there's so much more to these systems than we initially thought.
They're powerful, but they're also complex.
And we're just starting to scratch the surface of what they can do.
So for everyone listening out there, keep learning, keep asking questions.
And don't be afraid to, challenge the assumptions about AI.
Because the future of AI, it's
Yeah.
not something that just happens to us. It's something we create together.
That's right. Thanks for joining us on this deep dive.
Until next time.